Myself, Dr. Amit Kumar Yadav, Assistant Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana. Today I am going to start Generative Artificial Intelligence Model. When we say Generative Artificial Intelligence Model, it means it can generate data by its own when we put certain data sets. It means that generative AI learns the patterns in the data and it can generate the text, video, what instruction we have given to it. Its example is say chat GPT. So here we will see what are certain foundation of say generative AI. First, let us take convolutional neural network. We will see the basic concept related to convolutional neural network. Then we will see its implementation on say short example types of problem. Try to see first what is difference between say artificial neural network and say deep neural network. When we consider the artificial neural network, this is a schematic diagram of say artificial neural network. It has say three layers. This is input layers, hidden layers and output layers. But when we consider say deep neural networks, this is say input layers and this is output layers. Between input and output layer there is more than one hidden layers which is shown in the figure. So how we can define or differentiate deep neural network from artificial neural network? In deep neural network we are having more than one hidden layers between input layers and say output layers. So how we can define say deep neural networks? It is a say type of artificial neural network with multiple layers. Multiple layers, it is here it is called as a hidden layers between input and output layers. And and these multiple layers enables it to learn from data, and it can model complex patterns and relationships. The key feature of deep neural network is their depth. Depth here means or it refers to number of layers that exist between input and output. Now introduction to convolutional neural network. Convolutional neural networks are a type of deep neural network. It is used for image processing tasks. It learns spatial hierarchies of features automatically. So this is called as important parts of convolutional neural networks. The major application of convolutional neural network are object detection, image classification, and segmentation. Try to see the architecture of convolutional neural network. So basically it is used for say image. So here this is called as say input layers. Here we are having certain pixel. This is called as a pixel, means smallest part of the image. Then we are having the convolutional layer. On say convolutional layers, the spatial features of the image take place. Then we are having these pooling layers, and this pooling layers is used for say feature extraction. It means that on this pooling layer, important features of image get extracted. After this pooling layer, it will pass through this fully connected neural networks. On this fully connected neural network, the classification task takes place. Now we will see this part in details. Key components of convolutional neural networks. First one here, convolutional layers. It extracts spatial features. Pooling layers. It is used to select important features. Therefore, this pooling layer is used for reducing the dimensionality in the model. Once dimensionality in the model get reduces, it increases the training capability of the model, and error matrix between predicted and measured or true value get decreases. After pooling layer, we are having this fully connected layers. Its function is to perform classification. In fully connected layer, we are having say different types of activation function, and these activation function it introduces non-linearity in the model, and this is used to solve the complex problem, or we can say that complex real problem what we use to solve with the model. Then we are having loss function and optimization. It is used for guide learning. Now, how we can represent image as multi-dimensional array. In convolutional neural networks, the image is represented with multi-dimensional array, and each multi-dimensional array is represented by grid of numbers, and this grid of numbers describe image picture. So what we can say that what do we mean by the image pixel? It is a representation of image in multi-dimensional array. Image as a grid. So image is made up of tiny unit, and this tiny unit it is called as pixel. Each pixel represents a color value such as red, green, blue for color image, and color image usually has three color channels, and these three color channels are red, green and blue. In each pixel, image stored three values representing the intensity of red, green and blue. After this we are having this multi-dimensional array. In convolutional neural network, this image is represented as multi-dimensional array, and this is called as tensor. This array has three dimensions for a color image. Here height, number of rows represent height of the image. Width is denoted by W. Number of column represent width of the image. Then channel C. So number of color channels, example 3 for red, green, blue image. It represented by channels. So let us take example. Suppose you have a color image of size 32 cross 32 pixel with three color channels are red, green, blue. The image is represented as 3D array with the shape here, height, width, channel. So here 32 into 32 pixel and 3 as a 3D array with the shape. What are computer vision application of convolutional neural network? Image classification, object detection, image segmentation, face recognition, optical character recognition, then medical image analysis, autonomous vehicles, self-driving cars. These convolutional neural networks have revolutionized computer vision. It extracts spatial features automatically. Application varies from object detection to medical diagnosis. As it as basically it this convolutional neural network is used for say image, therefore it play a very important role in medical diagnosis. By extracting image of certain disease from the body, it is widely used in AI-driven technology like autonomous system. And this autonomous system is used to take image and that image get processed by say convolutional neural network to make important decision. Therefore, this convolutional neural network very useful in say autonomous systems. Then we will see here gray scale image convolution. This gray scale image is represented as 2D matrix. Here height cross weight. Convolution applies a filter. This filter is also called as kernel to extract features like edge and textures. What is happening here? The kernel slides over the image, performing element-wise multiplication and summing result. So basically what are example of filters here? Sober filter for edge detection. Convolution operation on color image. Color images have three channels: red, green, blue. This is represented by RGB. Convolution is applied separately to each channel. The results are combined to generate final features map. It is used for extracting spatial features in color images. Padding in convolution. Now we will see what is basic concept or meaning of padding. It is adding extra pixel around an image before convolution. What are types of padding? First one say valid padding. It means no padding, shrink image size. Same padding. Here zero padding, keep output size same as input. Helps preserve spatial dimensions and prevent information loss. Convolutional neural network architectures. Convolutional layer is the core building block of convolutional neural networks. It applies a set of kernels to an input image for detecting features such as age, textures, and patterns. What is function of convolutional layers? Here feature extraction. It detects patterns such as edge, lines, and textures. Then filter application. Here kernel filter is applied to the image to compute new representation. Then stride and padding. Stride means how filter move across the image. Padding here adding extra pixel around the image to maintain the dimension. So then we are having activation function. Here we are using this ReLU activation function. ReLU means rectified linear unit. It is used to introduce non-linearity in the models so that complex non-linear type of problem can be solved. If activation function doesn't introduce non-linearity, then it is not possible for the neural networks to solve complex non-linear types of the problem. Pooling layers. Pooling layers is used to downsample the feature maps obtained from convolutional layers while preserving essential features. It helps in reducing computational complexity and it control overfitting by minimizing spatial dimension. Common types of pooling. First here say max pooling. Select maximum value from a defined range. Example 2 cross 2 window. Average pooling compute average value from a defined region. If a feature map of size 28 cross 28 undergoes 2 cross 2 maximum pooling, the output size reduces to say 14 cross 14. Flatten layers. This layer convert multi-dimensional feature map into one-dimensional vectors because we have to feed this image part to a fully connected layers. But the image is in a multi-dimensional part. It means that it has length, breadth and height. Therefore, this multi-dimensional feature map should be converted into one-dimensional vector. This process is performed by, say, flattened layer. It bridges the gap between convolutional pooling layers and dense fully connected layers. Example, if input is a 3D feature map of shape, say here 14 cross 14 into 64, the flattened layer convert it into one-dimensional vectors of size 14 cross 14 into 64. Here we will get 12544. Now we will see what do we mean by this features extraction. It is a process of extracting meaningful information from an image like edge, circle, square, sharp corner, etc. Try to see this figure here. It is a figure of say bike, and on this image feature extraction performed. And when we see this feature, here we are having some portion of the tire, some portion of the seat, again front portion of the vehicles. Then here we are having another portions of the vehicles. Here wheel of the vehicles. So because these are say important features which gives a meaningful, it is meaningful because by seeing this image we can know that it is a tire of a vehicle. By seeing this portion we can know that it is a seat of a vehicle, right? So that combined together allow identify a class of an object. So this feature extraction is a backbone of convolutional neural network. Image segmentation using convolutional neural network. Image segmentation is a technique in computer vision where an image is divided into different meaningful regions or object. Means we have to divide the image into different meaningful region or objects. It is used in application like medical imaging, here called tumor detection, self-driving car, detecting roads and pedestrian and satellite image analysis. There are two types of segmentation. First one here, semantic segmentation. It classifies each pixel in an image into category. Example, sky, road, car. Then we are having instant segmentation. Identify individual objects separately. Example, detecting multiple cars. try to see here semantic segmentation. It is an example of semantic segmentation where the goal is to predict class level for each pixel in an image. This is an image. When we do in here prediction part, here the image look like in this way. So by seeing this image, what we estimate that person bicycle background. This is called as semantic segmentation. Here you see this bicycle is given by say different color, say here green color, and this person is given by some different color, and this background is given by some different colors. Again here, this is an example of semantic segmentation. Here scene parsing. Now see here this background, this part, it is given by say different colors, and this part is given by say different color. This tree is given by say different colors. Okay, and this is here, this house is given by different color. This is called as semantic segmentation. Instant segmentation. So here this is a pictorial diagram of an a say car. So instant segmentation. Here we are having say different pixel of an image. Okay, for different types of the car. Here for this car it is different, for this car it is different, and for this car it is totally different. Now we will see architecture of CNN, that is convolutional neural network for semantic segmentation. First here encoder. It is used for features extraction. It works like regular CNN for classification. It consists of multiple convolutional and pooling layer which extract important features while reducing image size. Its example are VGG, ResNet, MobileNet. This MobileNet is called as pre-trained CNN models. Next here, decoders. It is here upsampling and pixel-wise classification. Decoder takes the reduced features map and upsample them to original image size. It utilizes technique called transpose convolution. This is called as deconvolution or bilinear interpolation to restore spatial information. Output is segmentation marks, where each pixel is labeled with category. Common CNN-based segmentation model, UNet, simple encoder-decoder model with skip connection for medical image segmentation. Fully convolutional neural network, usually convolution layer, no fully connected layers. Deep Lab by Google's, it uses address dilated convolution to capture better spatial details. Loss function for segmentation. Since in segmentation there is pixel-wise classification problem, we require a specialized loss function. First is cross entropy loss for multi-class segmentation. It is used when each pixel belongs to one of several classes. It compares predicted pixel label with ground truth labels. Then dice loss for imbalanced data. It is useful when segmenting small object, example tumors in medical image. It measures overlap between predicted and actual segmentation marks. Dice loss is given by 1 minus 2 into A intersection B by mod of A plus mod of B. A is the ground truth mass, B is the predicted mass. Image classification using custom convolutional neural network. Image classification is a task in computer vision where an image is assigned to a specific category or label. For example, classifying images of dogs and cats into separate classes. It is widely used in applications like facial recognition, medical diagnosis, and autonomous driving. CNN are commonly used for image classification as they automatically extract features from the image such as shape, textures, and edges. Then we will see development of an custom CNN model. A custom CNN model is a type of deep learning model which is designed for given data set instead of using pre-trained model. The steps to develop custom CNN are as follows. Step 1. Prepare the data sets. Collect and pre-process image. What we are doing here? Resize, normalize and augment the image. Then we have to split data into training, validation and testing. After this, build a CNN model. Basically, this CNN model has convolutional layer. It extracts features from image by utilizing filters. Then here we are having activation function ReLU. It introduces non-linearity to a network. Then here pooling layers. These pooling layers reduces features map size for improving efficiency. Pooling layer is of two types, max pooling and average pooling. Then fully connected dense layer. It makes final classification decision. Softmax oblique sigmoid activation converts output into probabilities for multi-class or binary classification. Train and evaluate the models. We are using training data to fit the model. Now, the validation data is used to tune hyperparameters. Then evaluate on test data to measure performance. Fine tuning the model. What do you mean by this fine tuning of model? Fine tuning improve model accuracy by adjusting pre-trained model on a new data set. It involves pre-trained models. Examples of pre-trained model are Visual Geometry Group 16, VGG 16, mobile nets. Then we are having freezing initial layers. This is used to retain learned features. Training only the last few layers on new data sets. Introduction to image classification. This image classification is a task of assigning an image to a specific category. Application object detection. Example of object detection are recognizing between dogs and cat. Medical diagnosis. It means detecting pneumonia from X-ray. Autonomous driving. Example, identifying traffic signs. CNNs are commonly used for image classification due to their ability to extract spatial features from image. What are workflow for image classification, dataset collection and pre-processing? Resize image to a fixed shape. Normalize pixel to bring down the scales between 0 and 1. Data augmentation, rotation, flipping, brightness adjustment to improve generalization. Model training uses CNN to extract features and classify image. Then we are having model evaluation. It measures accuracy, precision, recalls and F1 scores. Basically, in classification, we are using different error matrices. First one say precision, recall and F1 score. Now how we have to develop custom CNN model. Step 1, prepare data or use data set like means or custom data set. Then split data into training, validation and testing. In step 2, build CNN model from scratch. These CNN architectures include convolutional layers for features extraction, ReLU activation for nonlinearity, pooling layers, max pooling for downsampling, fully connected layers to make classification. Fine tuning of image classification using custom CNNs. What we have to do here? Choose a pre-trained model. Pre-trained model like VGG 16, ResNet 15 are trained on large data set like ImageNet. Prepare your data set means first of all we have to select a pre-trained CNN model. Then we have to prepare our own data set means organize the data set into training, validation and testing. Then load the pre-trained data model or import the pre-trained models. Add custom layers. Append your own layers, example flatten, dense, softmax to adapt the model to your specific classification task. Freeze base model layer. It means freeze the pre-trained model layer initially to prevent their weights from being updated during the first phase of training. Compile the model. Choose an optimizers, example Adams loss function, example categorical cross entropy, and matrix, example accuracy. Then we have to train the model with your custom data set, adjusting epochs and batch size. Unfreeze layer optional. Unfreeze some deeper layers after initial training and continue training with a smaller learning rate. Evaluate the model. Means test the model on a test set to assess performance. Save the model. Save the fine-tuned model for future use. Then we will see transfer learning. What is the meaning of, say, transfer learning? It means model developed for one task is reused as the starting point for a model on second task. This transfer learning is used for limited data, but it can leverage pre-trained model that have been trained on, say, larger data set. So in an other word, we can say that transfer learning is used on, say, limited data. Basically, we are having pre-trained data which is already trained on, say, larger data set, and we are having limited data. There we can use this transfer learning techniques. CNN architecture used in transfer learning. First one here, VGG16, VGG19. Overview. This VGG is known for its simplicity and deep architectures with 16 or 19 layers. It uses only 3 cross 3 convolution and 2 cross 2 max pooling layers. Used in transfer learning. VGG16 and VGG19 are widely used as base models in transfer learning, where pre-trained model convolutional layers are reused and fully connected layers are replaced. RESTnet residual networks. Overview. RESTnet introduced skip connection to allow gradient to flow more easily through deeper layer, and it prevents vanishing gradient problem. What do you mean by vanishing gradient problem? It happens in, say, deep learning neural networks, because we know that this gradient is dependent on, say, chain rule of differentiation. So when we are having multiple layers, so the gradient will become 0. This is called as vanishing gradient problem. Once gradient will become 0, the weight updation cannot take place, because when we see the weight updation equation, Wi plus 1, that is equal to Wi minus alpha, that is learning rate, into partial derivative of error with respect to weight, and this part will become 0. Therefore The bait updation, that is the one step ahead bait, is equal to say previous step bait. So bait does not get updated. Once bait does not get updated, the error cannot be minimized. And this ResNet, it is used in say transfer learning. Its architecture are ResNet 50, ResNet 101 are often fine-tuned for image classification tasks and are popular due to effective learning and depth. Inception V3 overview. Inception V3 uses inception modules to efficiently process images at different scales and reduce the computational complexity of deep networks. Inception V3 used in transfer learning. It is known for its efficiency and it is useful for tasks requiring fast training and good accuracy. MobileNet. It is designed for lightweight models, often used in mobile and embedded application. It uses depth sep- separable convolution to reduce number of parameters. MobileNet, it is used in transfer learning. It is ideal for application where computational resources are limited. Efficient net, optimized depth, width, and resolution of convolutional neural network in a balanced bed. It provides better performance and efficiency in comparison to other models. EfficientNet used in transfer learning. It is highly effective for tasks that require both high accuracy and efficient resource uses. What are say different advantages of transfer learning? Say faster training, improved accuracy, requires less data, which is very important. Then we are having cost efficient. It improves generalization. Generalization means ability of a network to give accurate result on unknown data or unseen data. Now, how we can implement this transfer learning? First of all, here load a pre-trained model. Use a pre-trained model such as VGG16, ResNet, or Inception. In Keras, you can load a model with include top is equal to false to exclude the fully connected layer. Freeze the pre-trained model. Initially freeze the layer of the pre-trained model so their weight does not change during first phase of training. So this is the meaning of the freezing and it prevents overfitting, allows the model to adapt faster. Add custom layers. What it means? Add new layers, example flatten, dense, softmax, to adapt the pre-trained model to your specific task. Example, classification into different number of classes. Compiles the model using an appropriate optimizer, loss function, and evaluation matrix. train the model on your on your custom data set for a few epochs. This phase adjusts the weight of custom layer. Fine tuning the model, it means after training the model, you can unfreeze some of the deeper layers of the base model and continue training with a smaller learning rate to fine tune the entire model. This is called as fine tuning the model. Now we will see steps of fine tuning. Freeze initial layers and train only the custom layer for few epochs. Then unfreeze some deeper layers of a pre-trained model. Third step, lower the learning rate to prevent drastic change to pre-trained weight. Continue training the entire model with smaller learning rate. Object detection. It is a fundamental task in computer vision which involves identify and localize object within an image or video. Traditional object detection relies on model like YOLO, you only look once, SSD, single shot multi-box detector, and faster RCNN. But due to advancement of generative AI, new techniques are emerging that leverage synthetic data, data augmentation, and self-supervised learning for improving object detection models. Application of object detection, autonomous vehicles, here cars, traffic sign detecting pedestrian, medical imaging, it means detecting tumors anomalies, retail's automatic checkout product detection, surveillance and security, face recognition, suspicious activity detection. Bounding box. It is a rectangular region that encloses an object in an image. It is used to specify location of an object detected by an AI model. Each bounding box is represented by coordinate here x minimum, y minimum, x maximum, y maximum. This is called as coordinate. Center base representation x, y, w, h, where x, y is the center of the box, w is the width, and h is the height. Intersection over union or IOU. It measures accuracy of object detection by comparing the predicted bounding box with ground truth box. How we can calculate IOU, that is ratio of area of overlap to area of union. Area of overlap is intersection of predicted and actual bounding boxes. Area of union, total area covered by both boxes. If IOU is greater than 0.5, it is generally considered as good detection. If IOU is less than 0.5, it is generally considered as poor detection. And here model needs improvement. Higher IOU means better localization accuracy. CUB 200 dataset and dataset classes. CUB 200 dataset Caltech UCSD BERT 200 is widely used dataset for fine-grained classification and object detection in bird species. It contains say 200 bird species, 11,788 images, bounding buses and segmentation maps. A dataset is a structured way to handle data for deep learning model. In PyTorch, a data class for CUB200 is created using torch.utils.data.dataset. How generative AI is used with CUB200. Generative adversarial network can generate additional bot image to improve detection accuracy. Diffusion model can create variant in lighting, angles and background to make the model more robust. Training and testing. Model training for object detection. Training and object detection model. Data preprocessing. Resizing, normalizing and augmenting image. Features extraction using CNN, example ResNet, EfficientNet to extract key features. Bounding box regression, predicting object location in an image. Loss function using IOU loss or smooth L1 loss to improve localization accuracy. Try to see the numerical here. An output image of one convolutional layer that is going to pool layer is shown below. The pooling layer has a filter with size 3 cross 3. What is the output image? After maximum pooling operation, average pooling operation, output image of convolution layer, it is given here output image of say convolution layer. So the pooling layer has 3 cross 3 filters. Since original image is 4 cross 4, apply a 3 cross 3 filter with a stride 1 or 2 would determine the output size. For simplicity, we assume a stride 1 which results in a 2 cross 2 output. Max pooling. First max pooling takes maximum value for 3 cross 3 window. Extract 3 cross 3 window, say top left. 3 cross 3 window, say top left. Here this part. Then we have to take a maximum value of all element here. So maximum value here we are getting here say 53. This is called as a maximum element. So first here we will take here top left 3 cross 3. 1 means 3 column 1 2 3, 3 row 1 2 3. This is called as a top left, means this part. So then we will take here maximum element. Here we will get 53. Top left. Then similarly top right 3 cross 3 window. Top right here. Again from all these element we have to take say maximum element. Then 3 cross 3 window bottom left. Again 3 cross 3 window from bottom left. So this matrix will come, and when we take maximum value from this, here we are getting say 89. 3 cross 3 window bottom right here. So here we are having say 84. Thus maximum pooled output here we get 53, 89, 84, 84. Average pooling operation. Average pooling takes the average value from each 3 cross 3 window. So compute average. First 3 cross 3 window, top left. Here take an average. Here we are getting here say 24.44. Second 3 cross 3 window, top right. Take an average. Here we are getting here say 31.44. Third 3 cross 3 window, bottom left. Here we are getting say 33.0. Fourth 3 cross 3 window, bottom right. Bottom right, what we are getting here? 32.22. Thus the average pooled output here, what we are getting here? This matrix. Key difference between maximum pooling and average pooling. Features operation: take maximum value in filter, compute mean of filter value. Effect: preserve dominant features surface, smoothness features map, reduce noise. Use case: features extraction, object detection, image denoising, and generalization. Now, an output image of a pooling layer that is going to flatten layer is shown below. Calculate output O1 value in the given architecture. Here, output image of a pooling layer. It is go to flatten layer. Then on hidden layer, we are having two ReLU function. Then output of ReLU function come to sigmoid layer, and from output of sigmoid layer, this is an say output. Extract input from say pooling layer. The given output of pooling layer is say this one 3215. Concept: flattening means converting a multidimensional to multidimensional matrix 2D or 3D into 1D one dimensional vector. This is necessary because fully connected layer, dense layer in neural networks, take a single vector as input, not matrix. In this case, since we already have 1D matrix, the flattening process simply keeps the same value as a vector, is this one. Compute hidden layer output. So here we have to compute say weighted sum calculation. The neurons calculate Hi is equal to W1 into X1 plus W2 into X2 plus W3 into X3 plus W4 into X4 plus weight, where X1, X2, X3, X4 are inputs from the pooling layers. W1, W2, W3, W4 are weights assigned to each input. B is the bias, assume 0 if not given. For each diagram, each weight is given as a zero point 0.1. So here we will calculate Hi in this way. Then we have to apply ReLU function. The rectified linear unit is the activation function used in say hidden layer. This ReLU function is defined as max of 0, x. It means if the computed value is positive, it remains unchanged, otherwise it becomes 0. Since 1.1 is greater than 0, output remains H hidden of ReLU is equal to 1.1. Here there is two hidden layers neurons. They follow the same calculation, both neuron output say 1.1. Compute output layer value. So the hidden layer output are fed into final output layer, which has sigmoid activation function. O-net here, say 1.1 into 1.1 plus 0.1 into 1.1. So O-net here we are getting say 0.22. Concept sigmoid function is used in the say output layers. Sigmoid function is given by 1 by 1 plus e raised to power minus x, and the range of this value sigmoid function varies between say 0 and 1. It is commonly used in say binary classification. So when we applied here say sigmoid activation function, here we are getting say 0.554. Then here we are having a grayscale image is represented as 2D matrix shown below. This grayscale is processed through convolution layers with below properties. Calculate output image coming from convolution layer. So this is given as grayscale. Here convolution layer we are having number of filter 1. Activation function ReLU is tried 1. We have represented the grayscale image into say 4 cross 4. Filter this one. Bias minus 4 activation function ReLU is tried 1. Compute output size. The output size of the features map can be determined using output size is equal to n minus f by s plus 1. N is equal to 4 input size, f is equal to 3 filter size, s is equal to 1 stride. Output size that will be equal to 4 minus 3 by 1 plus 1, that is equal to 2. So output features map will be say 2 cross 2. Then here apply convolution. We slide the filter over image and compute say dot product. So top left 0 0. So we have to apply here this ReLU function. We are getting here 0. Top right 0 1. This is convolution part. Then we have to apply this ReLU function. Here we will get 0. Then bottom left, again here convolution part. Then apply ReLU function. Here we get 0. Bottom right, apply convolution. Then apply ReLU function. We are getting here 31. Output image, this is the matrix of the final output after convolution, bias addition and ReLU activation function. Then update the weight and bias parameter of given ANN model using backpropagation algorithm for one iteration. Initialize weight and bias parameter, which is shown in the figure. Here weight are given, bias are given, sigmoid activation function. Actual output y is equal to 0.8. Then we have to perform one iteration using backpropagation algorithm to update the weight and bias. So given data input here say x1 0.1, x2 0.3, x3 0.2, weight W1 0.2, W2 0.1, W3 say 0.3. Bias B is equal to 0.1. Actual output y is equal to given say 0.8. Learning rate eta is equal to 0.1. Activation function sigmoid. So forward pass, we have to calculate net input to the neurons. It is given by z is equal to x1 dot w1 plus x2 dot w2 plus x3 dot w3 plus bias. When we will put all this value, we will get here z is equal to 0.21. Apply sigmoid activation function 1 by 1 plus e raised to power of minus z. Here z is equal to 0.21. When we approximate this one, here we are getting say 0.552. Compute the error. Y is equal to half y minus yp whole square. So here half 0.8 minus 0.552. So when we will do here calculation, here we are getting 0.03. Derivative of sigmoid function here, sigma dash z yp into 1 minus of yp. When we put all this value here, we are getting 0.247. The gradient of error with respect to output, partial derivative of e with respect to yp. When we compute this one, we are getting here minus of 0.248. The gradient of error with respect to z, this one. When we put all this value, we are getting here minus of 0.0612. Then using weight updation rule, Wi new is equal to Wi minus eta into partial derivative of E with respect to Wi. When we put all this value, and we know that partial derivative of E with respect to Wi, that will be equal to partial derivative of E with respect to Z into xi. So delta Wi, we will put all this value here. Then we will calculate Wi new by using this equation. Similarly, for weight updation W2, then W3 for bias updation. That's all. Thank you.